Boom! Yes, folks, Hume again. So we're continuing with our series on coordinate geometry and straight lines. All right. So in this series, I want to deal I want to deal specifically with the whole question of what we refer to as the line segment. So if you find my face looking tired and the eyes looking tired, and you see the bags under the eyes and my eyes a little red and thing, yeah, that is fatigue. That is me more or less going all out to get the coordinate geometry ready, right? This video would have been made on the 30th of August 2020, right, at the beginning of the road to January in earnest, right? We would have covered two topics before. We would have covered Pythagoras theorem and trigonometry. We are about to start straight lines, all right? And I'm saying all of this just to remind you, mind you looking at the video, that there's a particular work ethic required, all right? I as your teacher would have to put myself under stress whenever that is necessary to get the job done. You too would be required at some level to put some stress on yourself. You don't necessarily want to compromise your health. You don't want to, stress out yourself to the point of getting sick, but at the same time, sometimes you had to go the extra distance. You had to go the extra mile. All right? So keep that in mind as we go forward. So in coordinate geometry and straight lines, we have this thing that we refer to as a line segment. All right? So the particular vocabulary, line segment, right? As the phrase itself implies, a line segment is simply a segment of a line. All right? And a part of a line, a portion of a line. So you have some examples here. This is a line segment, right? Remember, basically what happens is that a straight line, you could extend the line in both directions for as far away and as long as you care to do so. So I could take this line and stretch it out like this, all going as far as I wanted to go, right? I could do the same thing here, going as far as I wanted to go. I have another line segment here, OS, I could do that. I have another line segment, OT, O here and T here, I could do that, right? So I could extend a line as long as I want to. But because we're dealing with particular limits in terms of the space that we have to operate in, we cannot do that. So we basically truncate the line. Yes, go and look that up in the dictionary, right? We truncate the line, we cut it and we define what we refer to as a line segment. All right? And we could do all kinds of mathematics on the line segment with the understanding that whatever we do here, we could apply to the entire line. So for example, we could find the gradient of our line segment, right, which you will see a little later on. Not in this video, but later on the platform. So we could define the gradient of our line segment, and if we do that, we understand that as we extend the line in both directions, that would be the gradient of the whole line, the entire line. All right. We could also define the midpoint of a particular line segment. Now, of course, the midpoint will be specific to each line segment, because if the length of the line segment changes, then the midpoint of the line segment will also change. All right. So as we're talking about the length of the line segment, yeah, watching the clock. As we're talking about the length of the line segment, I want to talk about that in particular. I want to talk particularly about the length of the line segment and the midpoint of a line segment. Now, I have 4 line segments on this diagram here. You can see 2 of them very clearly. This is the point, the origin here. The origin is the point 0, 0, right? I would have discussed that in a previous video, how we notate the points and all of that. You have the point P86 here. 8 on the x-axis, followed by 6 on the y-axis. All right, and then you have a line segment here defined by 2 points. The point R, 12, 10, 12 here, and 10 up like that. And defined also by the point 18, 2, 18 here, and 2 up like that. You have 2 other line segments. One line segment, OS, running on the x-axis in the negative direction. So this line segment OS is defined by the points 0, 0 and 0 minus 10. This line segment OT is defined by the points 0, 0 and let me say that. This line segment OS is defined by the point 0, 0 and minus 10, 0. Remember the x-axis, the x-coordinate, is always written first. So you go minus 10 in the left. Minus 10 to the left is, 10 to the left is negative 10. That's minus 10. And because the point stays on this line, you have no movement up or no movement down, so the y-coordinate is 0. On the flip side, you go in 10 down. So it will be minus 10 as the y-coordinate. Remember, the y-coordinate always comes after. But because we go in down exactly on the y-axis, you have no movement to the right or no movement to the left. So the x-coordinate is 0. So this is the point T, 0 minus 10. Alright, so by this point you would have gone through some level of practice in terms of identifying points on the coordinate axes. So these points shouldn't cause too much of a problem. I try to choose simple points. Of course, as you get deeper into the topic, you'll find yourself dealing with points where the coordinates are not as neat as these here. You might get 3.5, 2 and 1/3. Them kind of coordinates, right? Coordinates that are not exactly whole numbers or integers. All right, so let us start, for the sake of simplicity, by considering the line segments that are on the axes. All right, so look at the line segment OS. So again, we're gonna get into some jargon here now, right? Whenever we write line segments in coordinate geometry, you write the two endpoints together. Now, anytime you have a situation where, well, I mean, it's not hard and fast, but the convention is to write the origin first. If the origin is in fact on one end of, the line segment. So in this case, the line segment will be defined. How do we write this? Hold on, I seen a mistake here. This would be QP PRS. This would be S here. No, this would be PQR. This would be R, right? And this would be Q. Right? Right. Now we notice I'm not editing out the errors, right? Because in our real class, you would have moments like this, where the teacher make a mistake and you have to correct it on the board, etc., etc., etc. Right? So we're trying to make the thing as real as possible, given the fact that we're in a remote-ish kind of situation where you're home or wherever you are watching this via the video. So we have a line segment. Now it really doesn't matter practically which letter you put first. So I could define the line segment as, I could define it as SO, or I could define it as OS. The important thing is that the points denoted by these two letters are the points on the two ends of the line segment, right? Those are the endpoints that define the line segment. So in this case, I will stick with the convention of writing the origin first, all right? So in this case, I will go with OS, all right? So OS is one line segment. So the line segment OS, right? Now, because the line is horizontal, right? Horizontal, yeah? We could actually count the units and figure out what the length of the line is. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the length of OS, which we could write as, watch it now, we could write this. The length of OS, which is the absolute value of OS, just a little jargon there, is equal to 10 units. Alright? Let us say for the sake of argument that the units are in fact no, let me just leave it as 10 units, because the units could be anything. Alright? Right, 10 units. Same thing here. because the line is vertical now, which is that it lies directly on the y-axis, you could actually measure the length of the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, we see that the length of OS is 10. So again, you could write this as length of OS is equal to 10 units. Right? This is one way to write it. You could write it as that as well. Again, I'm just introducing it to the jargon so that you have a familiarity with how the thing is done. All right? Now, what happens when we don't have a horizontal line or a vertical line? We have a line slanted at an angle. Right? In this case, the line segment is defined by the points O and P. All right, so I have another line segment OP, and yes, I design everything here where the lengths are the same. The idea is that we have to develop some method to find the length of our line segment if the line segment doesn't exactly lie on one of the axes, horizontal or vertical. All right, so OP is also 10, right? So the length of OP is also 10 units. And I'm going with the shorthand form now in the interest of space. All right? And the length of, well, it could either be QR or RQ. It doesn't really make a difference. So the length of RQ, right? Come. Let me write this thing properly now. The length of RQ is also 10 units. Yeah? So you have 4 line segments. We didn't write OT. All right, so I could, having already discussed this, I'm gonna rub it off now. Right? You on the video always have the option to rewind. So the length of OT is equal to what? Same 10 units. Right? 10 units. And those of you who do an add maths, you'll find yourself having to use this notation a lot when you're dealing with straight lines and coordinate geometry in section 1 and vectors in section 2. Yeah? So each line segment has a length of 10 units. Horizontal, we're on the x-axis, so we could measure it off easily. Vertical, we're on the y-axis, the measurement is the same. What happens then when we have a line at a diagonal? So what I would have done, I start from the simplest possible diagonal line that we could deal with in coordinate geometry, which is a line that passes directly through the origin. Once we move one of the ends from the origin, as we did here, you'll see that it gets a little more complicated, but I will do the 2 and then we'll develop a general formula for any line. All right, so we're basically looking to develop the formulas for the length of a line segment, and we're also looking to develop the formulas for the midpoint of a line segment. So as we're on the topic of the midpoint now, let us deal with that. Same story again. Because the line here is from 0, 0 to minus 10, 0, we could clearly see that the midpoint of this line is the point here. This here is the midpoint, right? And the midpoint, let us call it, normally we use the letter M for midpoint, right? But because we have all these different line segments, I would use different letters. So since this is the first one we do, we call this the midpoint. M is the point minus 5, 0. We could see that. Same story here. Because we could just count manually going down, we could see here that the midpoint is, like we call this one N. The midpoint N is the point 0, minus 5. What is the midpoint of this line and what is the midpoint of that line? That's what we're going to find out now. So I'm going to leave those calculations for the video following this one. This video, we basically set up the scenario. We build up the argument, all right? Starting with a line, a horizontal line on the x-axis, a vertical line on the y-axis, we show certain things, and then we're going to expand the argument now to lines that are not horizontal or vertical, starting with a line that actually passes through the origin. Alright, so check out the next video coming up after this. We're going to develop the whole algebra for this setup here.